The future of flight has always fascinated humanity. From the earliest sketches of Leonardo da Vinci's flying machines to the roaring engines that carried us through the skies in the 20th century, our desire to defy gravity has been relentless. Yet even with all our progress, the aircraft industry today still relies on outdated principles: jet fuel, complex mechanical systems, and enormous operational costs. The time has come for something radically different. The question is, what comes next? If we take a closer look at how technology is reshaping our world, one thing becomes clear: change doesn't happen slowly anymore. It happens in leaps. From smartphones that replaced entire industries to cars that drive themselves, the pattern of disruption keeps repeating. And now, that same wave of transformation is heading straight for the skies. More specifically, it's targeting an overlooked corner of aviation: helicopters. For decades, helicopters have been symbols of versatility used by rescue teams, filmmakers, the military, and wealthy executives alike. They can take off and land vertically, access remote areas, and hover with precision. Yet they've always been incredibly expensive, loud, high maintenance, and dependent on fossil fuels. For the average person, they remain out of reach, a luxury rather than a necessity. But that barrier might soon crumble. Thanks to the same forces that revolutionized cars: electrification, automation, and mass production. Imagine a world where helicopters or something very similar become as common as electric cars. Imagine walking outside, booking a quick aerial ride on your phone. Within minutes, a sleek, silent, fully electric aircraft descends from the sky to pick you up. It's not science fiction anymore. It's the next logical step in transportation evolution. And there's one name that keeps coming up whenever the world dares to dream this big: Elon Musk. Now, Musk is a polarizing figure. Some see him as a visionary pushing humanity forward. Others think of him as a self-absorbed billionaire, obsessed with fame and stock prices. But one thing is undeniable: he doesn't think small. Whether you admire or criticize him, his influence on modern technology is impossible to ignore. From PayPal to Tesla, SpaceX, Neuralink, and the Boring Company, Musk has consistently taken ideas dismissed as impossible and turned them into functioning, profitable realities. And now, whispers from within Tesla's development circles suggest something extraordinary is on the horizon: the electrification of flight, not just airplanes, but vertical takeoff and landing vehicles, commonly known as VTOLs, or electric helicopters. These aren't conventional rotorcraft as we know them. They're smarter, quieter, and infinitely more efficient. They represent a vision of aerial mobility that could redefine how humans move through cities, commute to work, or even travel across regions. So how do we get there? To understand the future of aircraft, we have to look at what's been happening on the ground. Tesla's electric vehicle revolution didn't just change how cars are powered. It changed how we think about energy itself. The key isn't just the vehicle, it's the battery. Batteries have become smaller, more energy dense, cheaper, and faster to charge. The 4680 cell developed by Tesla, for example, represents a leap in power-to-weight efficiency. And when you combine that kind of innovation with aerospace engineering, something magical happens. Electric propulsion changes everything. Unlike combustion engines, electric motors deliver instant torque, need less maintenance, and operate almost silently. They don't require complicated gearboxes, fuel lines, or exhaust systems. For a helicopter war, an eVTOL weight translates to lighter weight, fewer moving parts, and significantly lower costs. Add in regenerative braking and advanced aerodynamics, and you start to see how electric flight could become affordable for the masses. Of course, skeptics argue that batteries are still too heavy for vertical flight, and that used to be true. But look how fast progress is accelerating. Tesla's latest generation of batteries already exceeds 350 watt-hours per kilogram, and research prototypes have surpassed 500. When combined with lightweight, composite materials like carbon fiber and advanced AI-assisted flight systems, a fully electric vertical aircraft becomes not only feasible, light becomes inevitable. This is where Elon Musk's strategic genius shines. He doesn't just invent new machines. he builds entire ecosystems around them. Tesla's charging infrastructure, Starlink satellite network, and AI software could all interconnect to support aerial vehicles in ways no other company could. Picture this: a fleet of Tesla aerial taxis operating autonomously, charged by solar energy, communicating through Starlink, and maintained with the same over-the-air updates as Tesla cars. The same principles that make the Model 3 or Model Y efficient and affordable could apply to the skies. The economics are compelling. Traditional helicopters cost millions to buy and thousands per hour to operate. They require constant mechanical inspection and skilled pilots. An electric helicopter, on the other hand, could be mass-produced with far fewer parts, reducing both manufacturing and maintenance costs. Battery swaps or ultra-fast charging pads could replace refueling. Autonomous navigation would remove the need for a pilot altogether. Within a decade, taking an electric air taxi could cost little more than a long Uber ride. The environmental benefits are just as profound. Aviation contributes a significant share of global carbon emissions. Electric are among the worst offenders per mile. Electrifying this segment could drastically reduce urban noise pollution, lower emissions, and make short-distance air travel sustainable. Instead of a roaring engine, you'd hear only the gentle hum of electric rotors cutting through the sky. Cities would finally breathe easier, both figuratively and literally. But to make this happen, innovation alone isn't enough. Infrastructure needs to evolve. That's why Musk's vision extends far beyond vehicles. He understands that technology succeeds when ecosystems support it. Just as Tesla built superchargers before mass EV adoption, a network of vertiports could be constructed, compact landing and charging hubs located atop buildings, parking lots, or transit centers. These would serve as the backbone of urban air mobility. Powered by solar panels and backed by Tesla's energy storage systems, critics often question Musk's timeline. They say his ideas are too ambitious or that he overpromises. But history shows a different pattern. SpaceX's reusable rockets were laughed at. Now they're industry standard. Electric cars were considered a niche luxury. Now they dominate markets worldwide. Musk's teams at Tesla and SpaceX have repeatedly achieved what experts said couldn't be done. So when rumors surface that Tesla is developing an eVTOL, or something close to its hits, worth paying attention? Interestingly, Musk himself has hinted at the concept multiple times. Years ago, he mentioned the idea of a supersonic electric jet capable of vertical takeoff and landing. At the time, it sounded outrageous. But today, with advancements in aerodynamics, materials, and AI-assisted flight, it seems far less far-fetched. The transition from cars to planes isn't as massive as it looks. It's simply a change in physics, not philosophy. The same principles of efficiency, sustainability, and scalability apply. So what would an electric helicopter from Tesla actually look like? Picture a compact aerodynamic body, sleek curves, minimal drag, composite frame. Instead of a single large rotor, it might use multiple, smaller electric rotors for stability and redundancy. Similar to a drone, but on a larger, human-carrying scale. Inside, the cabin could feature Tesla's signature minimalist design panoramic windows, comfortable seating, a touchscreen interface, and AI-powered navigation. The flight system would be fully autonomous, guided by sensors, cameras, and satellite data, ensuring smooth, safe operation without a pilot. Charging would be wireless or rapid through Tesla's existing supercharger network. Upgraded for aviation. The onboard computer could sync with the Tesla app, allowing users to summon flights, track routes, and manage schedules seamlessly. Starlink connectivity would ensure uninterrupted communication and GPS accuracy, even in remote areas. And thanks to Tesla's growing expertise in battery recycling and energy storage, operating costs would stay low while environmental impact remains minimal. The potential applications are enormous. Emergency services could reach accident sites faster than ever. Cargo transport could become cheaper and cleaner. Rural areas cut off from major highways could finally gain quick, affordable access to cities. Even tourism could transform, with aerial sightseeing becoming accessible to ordinary people. For corporations, electric helicopters could replace short-haul flights, saving both money and emissions. The ripple effects across industries would be transformative. Still, there will be challenges. Aviation is one of the most heavily regulated sectors in the world, and certifying a new aircraft type is no small feat. Battery reliability, weather resilience, and air traffic management all pose hurdles. Yet with AI-driven safety systems and redundant flight controls, electric aircraft could actually become safer than traditional helicopters. Unlike fuel-based engines that can fail catastrophically, electric systems can distribute power across multiple motors, ensuring stability even if one fails. Governments are starting to recognize this potential. The US, Europe, and Asia are all funding advanced air mobility projects, and private startups are already testing prototypes. Companies like Joby, Aviation, Lilium, and Archer are racing to commercialize.